This is a lecture that was given at the University of Michigan Biological Station in May of 2020. The name of the lecture is Framing Approaches to Climate Change Problem Solving. I'm Richard Rood, University of Michigan, Department of Climate and Space Sciences and Engineering. The outline of the presentation is first to have a little bit of background of what I mean by problem solving, then talk a little bit about framing the challenges of climate change that we have based upon some temperature observations and some conclusions about what we are facing. Then I want to put climate change in context with many other societal issues and challenges. And then I want to shift over to this idea of taking control as individuals, and then I will have a wrap-up and some final comments. What do I mean by climate change problem solving? Over the last 15 years, I've been involved with the development of a set of courses developed to support the Applied Climate Master's degree in our department, CLASP, Climate and Space Sciences and Engineering. This curriculum taken as a whole introduces climate science and a basic science background. It introduces the intersection of climate science with other subjects, and then it introduces what I believe to be a unique approach of elements and techniques of complex problem solving. Starting in winter of 2021, we also plan to have a certificate in climate change solutions. So what do I try to teach in this curriculum? How do our students gain some control over how climate change will impact the planet and our lives? What are techniques of problem solving? And how do we accelerate the incorporation of climate change knowledge into design, planning, management, engineering? By gaining control, I want to recognize that we have always had to live with a changing climate. And because of this, we do in fact have a knowledge base and experience base on how to deal with weather extremes. We have the ability to look back over a number of decades and centuries and see a lot of human experience in adapting to changing climates. I also want to use knowledge to overcome the anxiety that leads to paralysis and inaction. This is a pretty basic human trait that when we're faced with large, complex problems, one of the things that we often do is to get very anxious about it. Sometimes we panic, and that leads to inaction. And this is not very productive. I also want to use knowledge to recognize and overcome barriers to applying climate knowledge, to recognize what is going on in the problems in the society and the conversations that we have. Rather than to continue to repeat that behavior, how do we tear down those barriers? And then I want to help to identify and implement no regrets mitigation and adaptation actions, where mitigation is the prevention of climate change getting out of control, and adaptation is responding to what happens. So towards that end, I have, with my colleagues, developed this approach to problem solving that has these 8 foundational elements. It relies on knowledge system theory. It relies on science usability theory. Then how do we frame problems? What are the communications and continuity requirements in addressing the problems? How do we engage folks in particular adaptation problems or particular policy problems? One of the most important things is how do we manage uncertainty? Because there's a lot of uncertainty about the details of our future climate. And then we talk about the skills for multi-constituency problem solving, and there's also some approach to decision analysis and decision making. I don't have the time to go through all of these or even to define all of these in this lecture, and I'm going to focus primarily on framing and some of the issues of communications and continuity. The first framing I want to do is to look at some climate data and what I think are some important takeaway messages from what we are already seeing in the changing climate. The Earth is accumulating heat, and the most convincing evidence of that accumulation of heat is the amount of heat content, which we could think of a little bit like the heating of the ocean, the amount of heat content that is being held in the ocean. We also have changes in the ice sheets, melting of the ice sheets, glaciers, and permafrost, and we see changes in ecosystems and agriculture, such as earlier growing seasons. Because of this accumulation of heat, sea level is increasing, ice is melting, the average temperature of the surface of the Earth is increasing, and the weather is changing. All scientific evidence, and really all of our behavioral evidence, suggests that these trends will continue into the foreseeable future. This is a graph of temperature anomalies, a graph of temperature differences. What is shown here is taking global temperature. We're going to average the temperature from 1951 to 1980. So this is a 30-year period, which is a common definition of climate. We are then going to subtract the other years, because this is annual. We're going to subtract the other years from this average, and then we're going to plot them up. The amount of time is from 1880 to the end of 2019, which could be called the modern temperature record, because this is when we have thermometers, and those thermometers are spread across the globe in a way that we're very confident in the quality of our temperature observations. If we look over the last 150 years or so, it's warmed about 1 degree centigrade relative to a pre-industrial base of 1750. There are many regions on the planet where we're already above a 2 degree centigrade warming, for instance in the Arctic. What's shown in these steps are averages from one decade to the next. So this is 1980, 1990, 2000, 2010. It almost jumps out that each of the last 4 decades are warmer than all the previous decades. The last time there was a month on this planet that was below the 20th century average temperature was February of 1985, which is about 35 years ago when I'm giving this talk. To put this in a human perspective, I often ask, when were you born? And I'll also point out that the median age of the world, according to the UN source that I used here, is approximately 31 years, the median being the age of which half the people are older and half the people are younger. And we see from this that more than half the people on the planet have not experienced a month when the global average was below the 20th century average. The change is accelerating. Regionally, there can still be periods when it's cold, and there can be an occasional cold record, but in general, record highs far exceed record lows, and cold air is becoming a more and more rare commodity. There is no evidence, again, that we will intervene and stop this trend. This is very much the same plot, except it's a shorter time period from the 1950s to 2019. It's for Michigan Climate Division number 3, which is the northwestern part of the lower peninsula of Michigan. Again, we've used a 30-year averaging period. If we look on this regional scale, which will have more variability than the global, then we see that each of the last 3 decades are warmer than the previous decades. If I take a measure of the spread of the averaging period, so this arrow here is showing the difference between the high and the low of the averaging period, which we might take as some sort of measure of natural variability, one of the things that you see is that this warming that we've seen in recent years is very large. In fact, the warming from one decade to the next often is comparable to or bigger than the spread of that averaging period, and we have this strong directional up of temperature. So we see this warming, and it would be stated with very high confidence that no one who is listening to this lecture in 2020 will see a decade that is not warmer than the previous decade. So we're going to be on this march of higher temperatures. As a consequence of this accumulation of heat, built environments are being affected and natural systems are being affected. And I think it's important to think of the balance that we're changing. We have developed as a society, as a civilization, a balance with our environment and a balance with our climate. And that's changing. That is one of the biggest challenges that we have, is that we are not especially good at working in unbalanced and changing environments or changing systems. There are a couple of important terms to place into the conversation at this point. One of them is rapid. The temperature rise and the accumulation of heat is rapid. And by rapid, I mean on a human lifespan. We're already seeing on 30-year lifespans basic changes in the average temperature, and we're seeing large changes in precipitation and other quantities as well. It's rapid on how long we build things to last, how long we plan for, and the ability of ecosystems to respond. I also want to introduce the idea of severity in this word dangerous, because dangerous has been used in a lot of policy discussions. There are some on the planet to whom the present 1 degree centigrade of climate change is clearly dangerous. This is especially true if you live on the coast and you're looking at sea level rise, or you're looking at the loss of ice in the Arctic, which then exposes the coast to far more erosion. Therefore, dangerous climate change is unavoidable, and what we need to do is to be limiting the disruption that will be caused by climate change so that we can more effectively manage those disruptions. So in terms of framing and communication, we are at the beginning of a time of rapid and accelerating climate change. The climate in 30 years will be different from what it is now. In 100 years from now, it will be different than that 30 years. We can influence where we will be in 100 years, but we, at this point, have relatively little influence over what we can do in terms of intervening and stopping this warming trend on the timescale of 30 years. One of the things that we need to do is to alter our behavior to incorporate this fact that the climate will be changing in ways that are directional, in ways that are more variable because there's more heat causing more energy. It's going to be unlike what we have experienced, and it's likely going to be worse than we expect. It will be dangerous. With that, I would like to put climate change in context with other aspects of what we do in our society. As I mentioned before, climate is changing and it's going to cause these things to happen. They're already happening. And the primary cause of this climate change is the emission of carbon dioxide, and that carbon dioxide is coming primarily from the burning of fossil fuels. There are many other things that do cause climate change, but carbon dioxide is the most important, and it's presently the most viable and important way that we might be able to manage climate change in terms of limiting how much warmer it will get. Carbon dioxide is emitted from burning of fossil fuels, the energy that we use, and 70 to 80% of the energy used by humans comes from fossil fuels. This has been a very stubborn number. I frequently have looked back all the way to 1973, and you can see this persistent number of 70 to 80% of the energy comes from fossil fuels. It's gone down a little bit in recent years because of renewables and efficiency, but still, this is a number that is very stubborn. We see an increase in emissions because energy use is increasing. The portion of the energy remains at this 70 to 80%. So that energy increase is causing an increase in emissions. We have had some success in decreases in emissions in some countries, and we've also made a substantial proportion of the increasing energy in developed countries to be coming from renewable energy. And I think this is important to note because if you just look at the curves without this context, that can be very discouraging. But in fact, we have proved that there are things that we can do to continue to have good energy sources and to manage our carbon dioxide releases. Next, I want to introduce standard of living. Our standard of living is directly related to energy access and energy use. We have essentially in the United States a policy for energy to be cheap. That policy has been around for a number of decades. The population is growing. Population wants to increase their standard of living, and therefore the population needs access to energy. Social justice. Raising the standard of living of a larger portion of the population is an issue of social justice. What we're really talking about here are people who need access to refrigeration and water, of which there are 2 billion or more people who don't have access to reliable essentials such as refrigeration and water. We're talking about jobs. But once we introduce social justice, it becomes a very complicated problem. It takes a complicated problem and makes it even more complicated. In the end, it's perhaps all about the economy. A growing economy is needed to provide jobs for a growing population. A growing economy is needed to raise the standard of living. A growing economy is needed for us to have things like pensions and retirement plans. And therefore, this idea of a growing economy enters into climate policy even at the level of the United Nations, where most of the statements of what we need to be doing to address the climate problem have the requirement that they do not stop sustainable growth. Presently, much of our economy is based on consumption of goods and services. Goods and services require the use of energy. Energy relies on fossil fuels at this point. And in the end, wealth, standard of living, vastly influence how we think about climate change. And then that brings us to values, both individually and collectively. For example, some people believe that it is our purpose on Earth to exploit the resources, and other people believe it is our purpose on Earth to provide stewardship. These individual and collective values have a very big impact on how we think about climate change. So climate is a priority. If we look at problems that we face as society, energy insecurity and economic insecurity, of which we have outbreaks of both every now and then, happen on relatively short time spans, and it's generally an outcome of those that climate change and other environmental issues become subordinate in order to address energy insecurity or economic insecurity. Both of these also potentially affect national security. And one of the reasons I want to put that there, when you think about national security and economic insecurity, then one of the things you are doing is talking about the real power structures of our society. Who has power, who does not have power? If these things threaten wealth, then I'll just place it as a rhetorical question at this point. Then how important will climate change be to our collectives? Another example that we're living through right now with COVID-19 is health security. And then when health security, say, has an impact on economic security, we also get back to the threat of wealth, the concerns about our retirement. Again, the rhetorical question, then how important is climate change? And then when we think of climate change and many other problems that we face, like ozone depletion, ocean acidification, the nitrogen and phosphorus cycles, land use, biodiversity, atmospheric aerosols and air pollution, pollution of chemical and plastic, and our problems with water scarcity and flooding, These are all related to each other. Sometimes they're in tension with each other, where you can address one and damage the other, but there are different priorities of where, when, who. And then, of course, there are, in this case, especially with the growing population and the increasing demand for resources, the questions of sustainability of the planet. What can we do to make climate a priority? When we start talking about climate, some people will take up the argument that if we address climate, we actually hurt our energy security. Some will make the argument to the other side, that it's good for energy security. Some make it it's bad. The same is true for economic insecurity. And with economic insecurity and energy insecurity, we once again get to this fact is once we introduce that on a short time scale, climate is often going to become subordinate. But we also have the fact that climate has an impact on health security, has an impact on national security. Frequently, we find that climate becomes more important to people because it gets amplified through these other issues. But there's some real challenges here. The relationship between climate and other issues is often indirect. Climate is often amplifying in an incremental way an already present issue that we know at some level how to deal with. It takes many years for the climate amplification of an issue to accumulate and become evident. Causation. If we reduce CO2 emissions, it's decades before we have an influence on the issue. These indirect and long time spans between how we behave to protect the climate and the benefits we see really make it difficult to elevate climate as a priority. And one of the things we actually see in recent years is the introduction of social justice as an important climate issue. And it will be interesting to see how the progress that was made on that in 2019 and early 2020 survives through the COVID-19 pandemic. So you can see the disruption again to our efforts to address climate change. So now, having introduced that context, I would like to talk about how do we as individuals perhaps start to take some control over this. I think it's important to realize that human-caused climate change is the consequence of the behaviors of individuals and societies accumulated over many years. It is the result of really an uncountable number of small and large choices, and many of these choices have made a lot of sense at the time and have had direct benefit to us as individuals and as societies. Therefore, climate change could be viewed in the traditional idea of the tragedy of the commons, where in a shared resource system that individual users act in ways that seem good, but it's ultimately contrary to the common good of all. A point I want to make is that since a lot of small actions got us to this point, we can also logically think that a lot of small actions can perhaps get us out of this situation. It will take some time. In fact, if we think about this problem and the complexity of the system, there is no one thing that we can do and hence solve climate change. There's no one entity to blame. There's no one entity that's going to pay for this. This ultimately falls upon us at a responsibility level that is both individual and societal, that we're going to have to do these things to address climate change. One of the reasons I wanted to mention this is that especially this term where I taught while the COVID-19 pandemic was unfolding and still unfolds, students became more and more discouraged about the role that individuals could take, and part of that discouragement came from observing that not everybody was, say, following the rules. And that's going to be the case with climate change. And one of the things that you have to do is to get enough people working on this, have the incentive structures to align so that solutions emerge from individual and organizational and local and regional activities. But if we are a little bit more formal and go back to that complex system of economy and social justice and climate and energy, where you can imagine taking and placing those cards in many different configurations, we always have this problem that we are dealing with a multi-criteria decision analysis. We may have multiple competing goals. We almost surely have multiple competing goals. And therefore, the solutions of the problems become fundamentally ones of collaboration, negotiation, and deliberation. They're not one where you say, the science says we have to do this, and hence that is something that we do. It depends upon your stakeholders. There's a trade-off analysis. There's something about this which is fundamentally political, and I don't mean political in the sense of the polarized politics of our culture right now. I mean political in the very basic nature of its policy, and there are winners and losers in virtually all policy decisions. Because of this, communication becomes in many ways more important than even the scientific knowledge. And then I mentioned this idea of continuity because one of the things that's truly important is that once we have solutions, once we get started, is that we build on those and we grow them and we try to scale and expand them across society. I've been involved in many projects where we have one good meeting and then nothing ever happens. And it's the continuity. How do we build off successes? How do we plan? How do we design and stick to those plans and design rather than starting over all the time, which becomes an essential part of successful problem solving. It's also important to realize that there is no one path for solving a problem. And this is true for solving many individual problems or even solving the global mitigation problem. There's not one path that we can look down and go, we need to do this, and it'll be done. We're down here in the bottom. It's a complex problem. Things are changing in time. Things are dependent on space. And all of these things, we need to consider them over and over again in the time. And we are likely only able to see, if we're down here, maybe we can see the next step. If we look out, say, at this progression here, all of these are likely to be productive solutions, and it's actually unlikely that we will have a single solution. So I think we have to actually understand there again that there's not one path, but there are many paths in a complex system like this that will lead to progress and ultimately perhaps to a satisfactory end. It becomes an art of choosing paths, and I don't have time to go through this in detail, but I've underlined these words. You look for the opportunity of a problem that can be addressed. When are people ready and ripe for that problem? You have to realize it's a collaborative process with communications. It's essential to define meaningful time horizons where you actually feel there's something you can get done. Take the first steps. And with regard to climate change, you need to monitor the evolution of climate change knowledge. What's happening? How are the guidance? How are the predictions changing as time goes? Then you need to refine your management planning goals. It's good to understand whether what you're doing has broader strategic benefit and perhaps should be scaled up. And then you repeat. And you repeat this because the climate is going to continue to change. I do want to introduce this formalized structure of response. We have carbon dioxide emissions and climate change. And our traditional response structure has been to think about mitigation, preventing further change, or adaptation, responding to change. And it's worth thinking about the attributes of mitigation and adaptation. Mitigation is anticipating a problem and trying to keep it from happening. Adaptation is reacting to a problem as it happens. Mitigation will require us to behave on a societal level, whereas adaptation, we can make decisions in a more autonomous fashion. Mitigation is ultimately global. Adaptation can be individual, such as armoring your lakeshore home, which may actually be an adaptation that's appealing to you, but is ultimately in the long term a bad adaptation strategy. So we have this individual aspect of here's something we can do. And then we get to what is often the big problem is mitigation. You really don't know what you're paying for since the benefits are realized so far in the future. And with adaptation, you do know what you pay for. In many ways, adaptation is easier than mitigation, and this is especially true if you have a lot of wealth and you think you have the ability to deal with whatever comes along. I also want to say that adaptation versus mitigation is a false choice. We are required to do both. And this idea of a false choice comes up again and again in problem solving and again in climate change discussions. Climate versus the economy is a false choice. Climate versus energy security is a false choice. Standard of living versus carbon dioxide could be a false choice. There are many others. But false choices are a form of rhetoric. They're a form of political argument, and that's what you're ultimately participating in is a political process. They can be a tactic to disrupt something. They're exceedingly attractive to people to engage in them and to argue over them, and they should be expected. So the savvy problem solver expects these things rather than laments over their presence and develops strategies on how to deal with them. Mitigation. We must mitigate. We must reduce our emissions, and we must enhance carbon removal from the atmosphere. We must break the relationship between carbon dioxide and energy. We must limit warming to keep carbon dioxide in frozen land and water from coming out into the atmosphere. I want to introduce this card here of carbon removal and the need for enhanced biological removal. We also need to develop technological removal. So when I say enhanced biological removal, I mean trees, I mean carbon in the soil, and perhaps carbon in the ocean system. That is pretty evident, not enough to reduce the carbon dioxide that we're emitting, and we have to develop the technological wherewithal to do that. And at the same time, we need to develop policy and law to govern that technological removal. I think at this point it's also a false choice of mitigation versus carbon removal and technological approaches to carbon removal. This is something I think we're going to have to do if we have any hope of limiting our warming to 2 degrees or 1.5 degrees on average. Climate intervention, previously known as geoengineering. This is something that we need to study because it's going to become very attractive to some people as the way to solve things. There are many, many risks associated with this, which is why I colored it red. Can we limit climate intervention to carbon removal? Because carbon removal is really an intervention into the climate. On the other hand, we could say that all the emissions that we're doing are climate intervention without a whole lot of thought behind it. And then I think it's important to remember all of these interrelated environmental changes when we're talking about climate intervention because, for example, if we somehow limit warming through shielding of the sun, we still have the problems of ocean acidification. On the span of multiple generations of human lives, planning our cities, planning our agriculture, managing our ecosystems, we are not going to go back, and conservation, preservation, and legacy all have to change. There will be loss, and we need to prepare for that loss. There will be loss of environment, there will be loss of place, there will be loss of species. There will also be opportunity and gain, and those who are going to do well do not become overburdened by the loss, but will look for the opportunity and the gains that are to be made. Because of these changes, we have to take a fundamental shift of thinking about how do we manage our best futures rather than how do we preserve the past. As I said before, there are many paths for any problems, and there are many, many meaningful problems. If we look in the mitigation world, it's really unlikely that we're going to have a national policy. And international policy, while important, it's fragile and of limited effect. So we really need to be looking at the individual organizational, local, and regional scales of what we can do. And there are many smart things we can do, such as efficiency and perhaps thinking about our diet a little bit more. However, we know about these things. Why haven't we done more of them? And that's actually a pretty important thing to think of, that we know that efficiency can save us money and reduce energy emissions. Why do we continue to do the things that are so inefficient? Looking on the adaptation side, it's perhaps easier to see this uncountable number of adaptation problems, ranging from, how do I protect my city against increasing extreme precipitation to heat wave management. These problems, however, do include the need to develop policies of what are going to be very big disruptions, such as managed migration away from coasts. They need to include things like codes and permits that anticipate climate change. It's very frustrating to work on a problem for 5 or 10 years and not be able to incorporate climate change because the coding and the permitting are designed for our historical weather and the climate and the variability that we expect. And we need to move into this idea of anticipating climate change and developing resilience. So we need to learn from the change. Climate change is not in the future. We are at this time of rapid and unprecedented change. We need to be using the current weather disruptions to learn and to prepare. We need to redefine our notions of conservation, preservation, and legacy. We need to prepare to deal with loss. And we need to develop a culture of anticipating and preparing for climate change and its consequences. And we need to remember our experience. Presently, we have made intuitive or codified historic climate variability into our behavior, into our buildings, into our agriculture, into our ideas of preservation and conservation. They have become so ingrained into these practices that we really don't even think about them. But if you were to look at what farmers are doing now, as growing seasons extend and as rain patterns change, they're adapting to climate change. We have proved again and again we know how to adapt, and we know how to incorporate climate variability and climate change into our lives. What we have to do is to make this conscious, and we have to do it again, and we're going to have to persist with this. We have to limit warming. We must mitigate and manage carbon dioxide and other waste products to limit climate change and other environmental damage. We need to consider the requirements for the technological management of carbon dioxide. What's the policy that supports it? What do we do with the carbon dioxide once we remove it? These are going to be major problems. If we don't limit warming, then we are very likely going to enter into something that's going to be even more rapid climate change, where the amount of the warming and the disruptions may be unmanageable. But we have time if we look at these problems and take them on in intelligent ways and allow solutions to emerge and support the emergence of solutions to address the problems. We need to move forward with choices at individual, organizational, local, and regional scales. It's unreasonable to expect there to be national and global solutions to these problems. It's easier to take action locally than globally. There's more stability in those decisions. It's easier to take near-term rather than long-term decisions. But unlike the path that we got here to this problem of a warming climate, these choices do need to consider their relation to climate change. What is the consequence? What are the accumulated consequences of the decision? These are hard problems, but they can be done. And we need to be confident that even though we don't see it on a day-to-day basis, that small choices accumulate into big outcomes. So the final comments. The science and technological barriers are far more tractable than the political, societal, and cultural barriers. Basic human urges of acquisition and safety and exploration, these motivate us to use energy in ways that are satisfying to ourselves and to our needs. We have a real human challenge in investing for the future, for the common good. We're not very good at that. And our ability and our willingness to respond to disruption, to disaster and change, we do that all the time, and it's seemingly often the choice that we want to make. But climate change provides a credible vision of the future. It's not a crystal ball. It's not magic. And if you think about that vision of, we know basically the environment in which we're going to be working, this is unique in all time. And in fact, it's your most certain knowledge of the future. If you were to start to think of it in terms of the techniques and the behaviors to gain control over dealing with climate change, then it could be the least frightening. It is our choice on whether or not we take these decisions and learn these techniques. Thank you for listening.